Good evening, everyone. Welcome to Unacademy. Welcome to Kreatryx channel. Welcome to the session of combinational circuits that is learn digital in 20 hours. So कल क्लास में हमने encoder decoder तक डिस्कस किया, encoder भी डिस्कस किया ना, normal encoder and mux demux are done. So we are almost completing the combinational circuits except encoder. Encoder में थोड़ा सा priority encoder तो बाकी है. After that we are going to start ROM and here the small topic we will touch and that finishes this chapter. इसके बाद आज हम कम से कम 20 क्वेश्चन सॉल्व करेगा. That is covering all the combinational circuits, which are the mostly the PYQs from different sources that can give you a great confidence of combinational circuits. ठीक है, चलो let's start that. Okay, so let's start. So आज problems भी करेगा, theory also. So अभी तो Unacademy पे ऑफर चल रहा है. You will be getting around what we call 36% you can save on Unacademy subscription using my code Shankar10. इसमें आपको extra months भी मिलेगा. There is a little price drop also altogether. You save almost 36% if you take subscription today itself. Today is the last day for this, and yeah, the new batches are also getting started today. So these are our rankers of ECE examination 2022 का toppers है ये electrical and ECE का. So the new batch is going to start today for 24 and 25 aspirants. I have started already signals and system in the morning, and also digital circuits is also started in the evening 5 p.m. session. So today the new batch started. You can join this batch if you are an aspirant of GATE and PSU of 2024 or 2025, where you get a comprehensive coverage of the syllabus by the top educators of the country. आपको सारे PSUs का PYQs cover हो पाएगा, doubt solving sessions मिलेगा, DPP you will be getting, that is the daily practice paper, and the many more benefits which can help you to get your GATE rank easily, right? So because you have sufficient amount of time without any delay, if you are an aspirant for 24 or 25, I suggest you can go for these batches. Okay, so I have started this today only. That is signals and systems. Today daily morning it is going on 7 a.m. to 9 a.m. Okay, so you can join this batch. You can save up to 36% if you take subscription today. Today is the last day for this offer. Okay. So these are our IRMS batches which can help for IRMS and civil service examination. You can use GATE and UPSC GSC combo. You can use my code where you get the GATE content and also UPSC General Studies content together. You can use my code to get the maximum discount possible. Right? So there are 2 more combat examinations are available this month. Don't miss this chance, guys, because you can get a all India level rank by comparing with the others. That is very important to rectify your mistakes in the real time environment before going for the real examination. Okay, so let's move quickly to priority encoder. ये सभी कल हो गया. I'll also share the notes in our Telegram channel, Shankar10. So normal encoder में दिक्कत क्या? More than one input is equal to one at a time, it will not work properly. So if more than one input is equal to one at a time, it should consider the high priority input and give it in the output. That is done with the help of priority encoder. Priority encoder means more than one input is equal to one at a time, it will consider the high priority input and give it in the output. That is done by the priority encoder. So let's have that priority encoder. Okay. See, I want to design it in order that I7 is having highest priority, I0 is the least priority. That is not the rule. You can take any priority, it is fine. So, okay, this is the highest priority, least priority, highest and the least priority. Okay, just a moment. Just a moment. Listen here. So here the design is like this. When I7 equal to 1, the remaining all inputs can be anything, whether it is 1 or 0, doesn't matter. I7 is the high priority. अगर I7 1 है तो बाकी तो 1 or 0 doesn't matter. मेरा output में क्या आना चाहिए sir? 1 1 1. When I7 is not present, when I7 is 0, but I6 equal to 1, remaining 5 4 3 least priority वाले inputs can be anything. It will give you 6. When I7, I6 are not present, I5 is present, 4 to 1 can be anything, 4, 3, 2, 1, wait, 1, 0. Here, when nothing is selected, enable is 0. It may be all zeros or it may be high impedance state depending on the design we have taken. Like I have explained in the yesterday class. Okay. Last वाला yesterday वाला class में जो explain किया ना the same way. Okay. Like this. So here when I5, I6 both are ones, what is the output you got? 6. But here when I5, I6 both are 1, when I6 is 1, I5 also 1. I6 1, I5 1 or 0 doesn't matter, you get 6 only if I7 is not present. This is how the design changes. Here we consider the remaining all inputs 0, but here the remaining low priority inputs को don't care consider किया. They can be any value, but it should consider the higher only. You can take anyone as a high priority, change the table accordingly. Because it is 8 variable function, it will be, I mean, it is of higher order to design and show you, as our syllabus is generally up to 4 variables, maximum 6. So let's take a 4 variable priority encoder. Okay. Now see here. Listen, here also the same rule. This one is the highest priority and the least priority. Okay. So when y1, why not? When enable is 0, remaining can be anything. What do you get? When enable is 1, okay. When I3 is 1, that is the high priority, remaining can be anything. I3 0 mein, you get this. So this place may, because it may give you wrong answer. Enable 0 may and I naught is equal to 1, you are getting same answer. Not to avoid that, it can be high impedance state also. It depends on the design. Now, if you see this figure, what is your y1? Y1 kya hai bhai? It is 1 under the condition of y1 is equal to 1 for 0 1 double cross. That is or 1 triple cross. दो possibilities है ना to get y1 equal to 1. इस पे you can say 0 1, you can take double cross का जगह पे double 0 0 1 1 0 1 1. So 1 triple cross के अंदर you can take 1 followed by all zeros to all ones. It will give you sum of the mean terms 4 5 6 7 8 9 and so on 15. ठीक है सर, हो गया. Then what about y naught, sir? Y naught equal to, it is 1 for 2 cases, double 0 1 cross 1 triple cross. So 0 0 1 0 0 0 1 1 क्रॉस की जगह पे 0 और 1 रख सकते हैं. ये तीन क्रॉसेस ना, तीन क्रॉसेस में सारे पॉसिबिलिटीज लिखना चाहिए. You should write all the possibilities here. That will give me sum of the mean terms 2 3 8 9 and so on 15. Now solve y1 and y0. Right, now let's fill for y1. Y1 is sum of the midterms of 4 to 15. Why not? Why not sum of them in terms? 2, 3, 8 to 15. So this will make one octet. This will make another octet. This will make an octet. This will make another octet. So what is your y1? It is equal to this octet के लिए this is I3, nothing is common here. For this octet, this is I2, nothing is common. So I3 plus I2. What about y0? It is I3 plus, what about this squared? I2 bar I1. Bas. So that is about your y1 and y2. Let's draw this figure. First one is I3 plus I2. Second one is I3 plus I2 bar I2. Y1, Y0. This is I3, I2, I3 plus I2 bar I1. Here, if I2, I1, both are ones. What is my requirement when to both the inputs are one? It should consider the high priority input and give it in the output. ये दोनों में high priority वाला क्या I2 और I1 में I2 आना चाहिए. So let's take, so I3 equal to 0, but I2 is equal to 1 and I1 is equal to 1. In that case, you get 1 bar is 0, 0 into anything is 0, 0 plus 0 is 0, 0 plus 1 is 1. So I am getting 1 0 in the output. Got my point? I'm getting 1 0 in the output. Yes, this is my desired condition. So here you may have some enable input का circuit logic भी design कर सकते हैं. So ये दोनों enable को देके output में दे सकते हैं. It is your convenience. When enable is 1, then only you get the output. Either you take a tri-state buffer and give it to the enable input. When enable is 1, then it will give you the output. नहीं है तो it will be equivalent to open circuit. Excuse me. Okay. So that is about your priority encoder. Here more than one input is equal to one also. It will consider only high priority and give it. So you can design the priority in any order of your wish. I have designed it with I3 is the high priority. A table change करके you may take I2 as the high priority or I1 as the high priority, I0 is the high priority. Any order is fine. Accordingly, we should change the input table that I have shown in the static. So the last part of this theory of the combinational circuits is ROM. ROM is a combinational circuit which contains decoder at the input stage and OR gates as the output stage. For example, see here. See, we take one n by 2 power n decoder. It's all okay. So like this, you have n by 2 power n decoder. At the output of the n upon 2 power n decoder, we connect n number of OR gates like this. They are not touching, they are just like this, not like this. Now, if you want to write 1 or 0 here, this is very simple. If you make a connection, when this line is activated, OR gate will give you 1. If you don't make any connection, when this line is connected, or line is, when this line is becoming 1, that is when input is all zeros, this line becomes 1. When there is no connection, OR gate will give you 0. The same happens from here. So whatever the data you require, accordingly you make or don't make any connection. Here don't think that all of them are same line. It is meaning is from here one input will go to OR gate. From here another input will go to OR gate. It is represented simply like this. Okay. So when a particular line is activated, because in decoder any one of them is one at a time, that particular line pay what happens, wherever you have connections, those bits will give you 1. No connection will give you 0. This is how we can store the data. So you have 2 power n locations. Each location will give you output may m bits. So that makes my ROM size is equal to 2 to the power of n upon m. Means 2 power n locations, and each location m bits. For example, if you have 1 KB ROM, 1 KB ROM, what is this? It has 2 to the power of 10 by 8. 2 power 10 locations and 8 bits at each location. So it is a combinational circuit only. Even it is having memory. It is not storing like a flip-flop with feedback and all. It is just giving you the required output with the help of make or break connections. Originally, we are not saving any data, but because of the connections, you are getting the data in the output. So this can be used for different applications. One of the application is to implement the logic functions. So see this question, implement the ROM following functions using the ROM of appropriate size. Here, 3 variables and 2 functions. What is the ROM size? 2 to the power of n by m. Okay. So take 3 to 8 decoder. 3 inputs A, B, C. Now see here. Okay, the function 1 is sum of the min terms 2, 3, 4, 6. 2, 3, 4, 6. The next function, sum of the min terms 1, 4, 5, 6. Okay. Okay. So when the particular line is activated, here nothing is connected. So 0, 0. Here this is connected. So 0, 1, 1, 0, 1, 1, 0, 1, 1, 1, nothing connected. So that will give you the required output. So this is the wrong implementation of the function. It is nothing but taking OR gate with 4 inputs at a time. From each node, you get one connection to the OR gate. So that is how you implement the functions using ROM, or you can use it to store the data. Say you want to implement a multiplier. First we take all input combinations. We write all output combinations. Say 2 2 is 4, 2 3 is 6. So when the input is 2 3, directly at that location we save 6. Means we make that connection. Automatically it can be used to implement a multiplier circuit just by saving the result already. Okay. Lookup table we call. Generally here normal ROM में both are fixed. That is the manufacturer will fix this. Okay, and the normal ROM manufacturer तो fix करेगा ROM में what is that R part and end part. Okay, normal ROM में manufacturer will fix. इसमें अंदर AND gate है ना, decoder के अंदर क्या AND gate है, ये है OR gate वाला part. PROM means programmable read only memory. इसमें OR part is programmable, AND part is fixed. There are two different cases: programmable array logic, where this is fixed, and this is programmable. There is another case where both are programmable logic array. Here this part is not in your hand ना. अगर ये भी आपके हाथ में है तो whichever end terms you require you take only them. Then it is programmable logic array बोलते हैं. Which are not in your syllabus right now, don't worry. But just for sake of continuity में तो explain किया. आराम से याद करने के लिए this is OR is programmable, here AND is programmable, ESE के लिए etc. Objective में it can come. Normally better to remember this table. That will finish the combinational circuits of your theoretical part. Theoretically, combinational is done. Now we do the problems on entire combinational circuits. Okay, so let's start that. Just a moment. I'm sorry. Yeah. So now problems on entire combinational circuits. Okay. So listen. First question. Let's increase the size. So these are some PYQs from different sources, mostly electrical ESC का GATE का है, ठीक है? So चलो let's start the question. N. So which of the following circuits converts binary number on the input into a one hot encoding? सर ये one hot encoding का मतलब क्या? One hot का मतलब only one bit equal to one at a time. Now, in the output only one bit is equal to one at a time. That is the meaning of the one hot encoding. Okay. So what it will do? Who will do this job, sir? 8 by 3 binary decoder nahi sir. 3 to 8 decoder. 3 input में depending on the input, it will take one of the output to be one. Now comparator, no. Generally comparator also it will do only one will be one because comparator में क्या होता है sir? A greater than B, A less than B, A equal to B में any one of them will be one. That is fine. But here convert a binary number. It is not converting. Comparator just give you the comparison. Here it will do the comparison, converting binary to octal and all. And in fact, there is no option which selects 1 and 3. 1, 2, 3 is given. It is not possible. So only 1 is the right answer. So let's go for the next question. चलो, this is an easy question. यार आप लोग आसान से कर सकते हैं. It is implementing exclusive NOR gate using the multiplexer. 7 seconds. So when logical input should be given for exclusive NOR gate, very simple to implement any two variable function using 4 by 1 mux. What is the input you should give is it is same as the output of the exclusive NOR gate. 1001 is to be given. You will get output is equal to this much. Whatever you require in the truth table output, that is to be given as the input of the mux. That is we have discussed in the class. So एडर का क्वेश्चन लास्ट में कर सकते हैं, पहले मार्क्स आसान वाले क्वेश्चन तो कंप्लीट कर सकते हैं. ठीक है. अगेन द नेक्स्ट क्वेश्चन. 5 seconds. Right. Here also, to make P XOR Q XOR R, you should give here R bar. So if you write expression, you get P XOR Q XOR R. So otherwise it is P bar Q bar R, P bar Q R bar, P Q bar R, P Q R. So this will be 0 0 1 0 1 0 1 double 0 1 1 1. Sum of the mean terms 1 2 4 7. Okay, that is nothing but P XOR Q XOR R. Okay, so that is a function implemented. So the next question also the same thing. छोड़ दो यार. This is the important simple question. Alternate logic symbols. इसमें 1 minute time तो ज़्यादा है यार. ज़्यादा time क्यों लेना? 30 सेकंड का टाइम ले लो आप लोग. Option A, B, C, D में whichever you feel correct, you can comment that option. Done. So NOR gate is nothing but A plus B whole bar equal to A bar plus B bar bubbled AND gate. And NAND gate is equal to क्या होगा? फिफ्थ वाला सिंबल कहाँ पे भाई? फर्स्ट वन 4, Q equal to 2. Then I will change. There is some mistake in this figure. Like this you can see. Now NAND gate is bubbled OR gate. XOR is equal to, okay, I'm sorry, this is not wrong. I'm very good. XOR is equal to complement of XNOR, that is this one, and XNOR equal to this one. So what is that? 4 2 3 1. 4 2 3 1, option B. I'll explain this. If one of the input A XOR B में, if one of the input is complemented, what happens? What is A XOR B? A bar B plus A B bar. But A का जगह पे here A bar is connected. Then normally A XOR B is A bar B plus A B bar. But here A का जगह पे you should take A bar. Then it will become A B plus A bar B bar. That is nothing but A XOR B. Got it? So this is A XOR B. So A XOR B is equal to A bar XOR with B or A XOR B का. Suppose A XOR B is A bar B plus A B bar. here B का जगह पे B bar ले, then what happens? You can see A bar B bar plus AB. That is nothing but A X NOR B. So A X NOR B is equivalent to A bar XOR with B or A XOR with B. Okay, both are correct. That's why X NOR B is A XOR with B bar. Same way, A X NOR with A bar XOR with B will give you A XOR B. You just write the expression and cross check. So let's go for the next question. This question is, don't think it is a microprocessor question hai kya? No, it is based on digital only, but application is maybe a microprocessor circuit. Okay, so what is the address to be selected here? Firstly, for this decoder to be selected, this should be 0, 0, and this must be 1. That is, this must be 0. Okay, no worries. So to get the output of the NAND gate equal to 1, SARI inputs must be 1. That is, this is 1, 0, 1, 0, 0, because there are bubbles here. That is the combination which can give you NAND gate output equal to 0. So for Wi-Fi to be selected, here it should be 1, 0, 1. So if you write A15, 14, 12, A11, A10, A9, A8, इस पे 15 क्या होना चाहिए सर? 15 तो 0, 0, 1, 0. 11 तो 11 to 1, and 10, 9, 8 must be 1, 0, 1. And here A3 to A0 can be all zeros to all ones. Okay, because they are connected to the internal. I mean, they are not given, so they are used for the internal address bus maybe of the other this particular chip. छोड़ दो इसके बारे में. So this must be 2. Hexadecimal means this is 13. 13 means A, B, C, D. And this will give you all zeros to all ones means FF, because 1111 is F. Okay, so the range of the address here is 2D002, 2DF. Okay, so 2D002, 2DF. Next, so if you are done with this particular class, combinational circuits में कोई भी क्वेश्चन आएंगे तो आराम से आप आसान से सॉल्व कर सकते हैं यार. Tomorrow we start the sequential circuits, and then we will discuss the data converters. Okay, these are the three chapters you should study for electrical engineering. So around 14 hours I may take it, and I will finish that part. Next, So there are 4 chips. It's visible. Okay, this is the common one, A0 to A9. I'll write them so that it will be more clarity for you. A10, A11, 12, A13, 14, 15. So this is the selection input S1, S0 of a DMUX. So 11, 10, 01, 00, right? So this is the RAM 4, RAM 3, RAM 2, RAM 1. This is the enable line. Now it is better, only visible. Okay, so there are there are 4 chips each of 1024 connected to a 16-bit address bus as shown in the figure. The RAMs 1, 2, 3, 4 respectively are mapped to the addresses for. So what are the addresses for which the RAM will be selected? The RAM 1, RAM 2, RAM 3, RAM 4 is the question. So take your time and try to solve it. Time up. So there are 4 chips. Okay. Firstly, let's make the design here. Okay. This must be 0, 0, 14 and AND गेट का सारे इनपुट्स तो 1 होना चाहिए ना. So AND गेट का सारे इनपुट्स 1 होना चाहिए, तो this must be 0 and this is also 1 and A12 and A12 is connected to S0, A13 is connected to S1. So A15, 14, A13, A12, A11, A10, A9, A8. Okay. 15 and 14 are 0, 0. A13 and A12 are used for selection of the lines. These are not connected to AND gate. But again, 10 and 11 are connected to the AND gate. So 11 must be 1, 10 is 0. Okay, these are connected to S1, S0. So you understand here, S1, S0 can be 0, 0. S1, S0 can be 0, 1. 1 0 1 1. Okay, so this will give me 0 1 2 3. right? So when it is 0, 0, 0, 1, 1, 0, 1, 1, so it will be selecting for 0, 0, 0, 1, 1, 0, 1, 1. It will be selecting RAM 4321. Okay, so this will be selecting. This is the address binary equivalent. So they can be again 1, 0. They can be all zeros to all ones. That can be remaining can be okay. So this will be what is that? 800 to 1011 means BFF. So you can say the address will be 08002 0BFF. Next 18002 1BFF, 28002 2BFF, 38002 3BFF. So these are the selections for RAM 1, RAM 2, RAM 3, RAM 4. Okay. So you can see. So what is the formula? 08002 0B double. So option D. I hope you understand. Okay. So firstly, the gate inputs I have selected such that it will give you one in the this AND gate, and these two lines can be 00011011 to select any one of the RAM, and A0 to A9 can be all zeros to all ones. So A0 to A9 all zeros to all one. This A10, this one S1 S2 remaining to according to the input of the gate connected. That will this S1 S0 can be 00 to what we call they can be 00011011 to select the different ROM. So it will give 0123, and this is fixed to 10. So here A9 to A0 can be all zeros to all ones, can give you 8002 to BFF for any particular ROM RAM. So this is these are the addresses selected. There is nothing here regarding RAM, but this is a question based on your basics of the digital. Okay, next question. What is the value of the N? This is a mux, output is connected to DMux. Time up. Okay. So for consider the logic circuit, uh, the input line I. Okay. So the input line I13. Okay. When you give 1101 here, then I13 is corresponds to the output line IN dash. What is the IN dash? You will be getting it. So firstly, understand 1101 is the input. 1101. Double D bar means 1 bar 0. Here C is 0, A is 1. 1 XOR with 1, 0. 1 into 1, 1. 0 bar 1. 0 into 1, 0. Whole bar is 1. So here the input selected is 7. So what do you get here? IN bar is nothing but, not bar actually, IN dash. It is I7 dash. Got my point? When you give 1101, that I13 will be selected here and I13 will come here. That I13 will be coming to which particular line in the output. So when you give to A, B, C, D में C0 and D1 all are ones, D bar is 0. In that case, you get XOR operation is 0, AND operation is 1, inversion is 1, 0, 1 is 0, whole bar is 1. So 7 will be selected in the output line. So the I13 will be given to I7 bar. It is not complement, just representation. Okay. Seventh line पे you will be getting. Next question. Okay, another similar model question. I give it a try. Right here, A bar into B bar, 1, S, 0. Right. What is the output function here is the question. So C bar, D bar, C bar, what is I naught? 1. D bar C, 0, 1, 5, what is the output? A bar, B bar. DC bar into S plus DC into 0. So here A bar, B bar, CD bar plus C bar, D bar plus C bar DS is the answer. C bar DS तो है. This can be written as A plus B whole bar. This can be written as C bar plus D whole bar. I'm writing according to exam. Complement by duality property. So I feel that A bar plus C bar plus D whole bar plus C plus D bar plus S bar whole bar C bar D bar option D is satisfied according to the option. Okay. Next question. Good. I feel we have done this. No. 3 to 8 people. Give it a try. Three seconds more, 2 seconds more, it's done. The function f of a is implemented by the circuit shown below. Okay. So here D must be 1. You get a 0 here and it is enable is selected. So here it is NAND gate is nothing but bubbled OR gate. Earlier I told when it is a active low, when you take NAND gate, it is representing min terms. Yesterday, last lecture, yesterday only I feel. If you take AND gate, it is implementing max terms. NAND gate, it is implementing min terms for the active low output. So, what are the min terms? It is representing sum of the min terms 0 to 5, 7. Okay. So, but D must be 0. So, listen here. You can do by different patterns. So, I'll do one thing. So, take A, B, C. So, the min terms 0 to 5, 7 are selected, right? 0, 2, 5, 7. So this will make a pair. This will make a pair. And what is the expression here? A bar C bar plus A C. That is A XNOR with C. But what is your F? F must be, F is equal to A XNOR with C. A XNOR with C, you multiply with D equal to 1 condition. So into D. Because D equal to 1 तो satisfy होना चाहिए ना. So this is XNOR symbol. Okay. So D into A XNOR C. Okay. So this some of the midterms will give you X nor C, but D compulsory one होना चाहिए to enable this. So D into A X nor C is the output expression. So there is a question on decoder. So electrical वाला बच्चों के लिए I have done sufficient number of questions so you can answer any PYQ. I hope if you attended this short duration session also, right? So any one multiplexer and one inverter is allowed to implement any Boolean function. Yes, you can answer this question. ये तो class में discuss तो किया ना. Read this. Right, time up. Suppose only one multiplexer and one inverter is allowed. Okay. If we have 2 power n mux plus one inverter, you can implement any n variable function. Okay. So, sorry, 2 power n minus 1 mux. Suppose 2 power 3 mux, 2 power 2, 4 by 1 mux and inverter is there, you can implement any 3 variable function. The same way, if you have 2 power n minus 1 mux, but 1 to 2 power 3. That is correct. 2 power n minus 1 mux. Say 4 by 1 plus inverter. Any three way. Right. Right. This is what we discussed in the regular class already. चलो next question. This question you can आसान से answer कर सकते यार. ठीक है 30 सेकंड टाइम ले लो. Time up. Yes, it is an easy question. This is what we discussed just now in our previous topic of this class. When I D3 is 1, baki to anything, it will give you 3. Yes or no? And when D2 is 1, you get 1, 0. When these two are not present, you get 0, 1. When all of them not present, you get 0, 0. Whenever You see here, no input is valid, input is applied, valid is equal to 0. And this V is telling you whether your input is a valid input or not. At least one input must be one. That is the meaning of the valid input. So what is the function of this truth table is? It is nothing but a priority encode. Out of the all inputs, whichever is having high priority, that will be given in the output. Right? Next question is ready for you. This question looks lengthy, complex, but it is already done in the class. You can do it easily, yeah. Please believe in me. You just read the question. If you read the question, that is sufficient to answer the question. Please give it a try. Okay, ready. So consider a multiplexer with X and Y as the data inputs. Okay, let's do. Rebind मेरा pause एक mux. Okay, 2 by 1 mux. X, Y are the data inputs and control input is Z. When Z equal to 0, it selects X and Z equal to Y, 1, it will select Y. I want to implement what is the function? Two variable boolean function T plus R. ठीक है sir? So OR gate ले लो. OR gate में you take Z equal to T. Then the other input R, you take it as 0, what happens? R equal to 1 happens. Sorry. T equal to 0 and 1. What are the outputs of the OR gate? This is what we have done in the regular class. Now, R plus 0, R. 1 plus R1. So these are the inputs you should give for I naught and I1. But I naught and I1 are nothing but X, Y. So X must be R, Y must be 1, Z must be T. X equal to 1. X must be equal to R. R to X. So wrong, R to X. Then 1 to Y, T to Z. Right answer. You may think that why you should implement T plus R plus T is also possible. Examiner given in the order of T plus R, I assumed Z equal to T and started. You can assume Z equal to R and start also because it is a commutative property. It will give you the same answer. But options, according to the option, one is only available. Okay? So it makes confusing, but simple you understand it is nothing but a OR gate only, which we have done already. ठीक है नहीं तो you can take its characteristic equation z bar x plus zx इसको हम t plus r करना चाहिए तो क्या करना it should be in the form of t plus t bar r that is a t into 1 that is x must be uh, okay that must be t plus r so y का जगह पे 1 होना चाहिए x का जगह पे r होना चाहिए बस in this way also you can do it next question जैसे एडर क्वेश्चन मैं तो लास्टली करता हूँ ठीक है मैंने ऑलरेडी बताया है सारे एडर क्वेश्चंस तो बाद में कर सकते हैं एट द एंड डिपेंडिंग ऑन द अवेलेबिलिटी ऑफ द टाइम Read this. Read it. Okay. Again, this is the same question. It's a and one, one, one. Bar है ना zero, zero, one, zero. Enable must be zero. Then only you get one here. So this must be compulsory one. ठीक है. And now compulsory Z must be one because enable is one. Then only it will be selected. So A not Z must be. This must be one means its inversion must be zero. So here you get y bar, y, x, x. Okay. So what is that? Which of the following represents a function implemented? When it is, you can see a input permanently fixed to zero, na? So y can be zero or one. So what is the value of your function is? You can say y bar. That is originally you can write a1 bar, a naught bar into I naught, a1 bar. Okay, a1 a naught bar into I1. Why I am taking a naught bar only? Why not a naught? Because a naught is permanently zero only. A naught 1 will never happen according to this particular figure. Now a1 a naught, what are they? a1 a naught bar, a1 bar, a1 kitna y bar whole bar is y, a naught bar, a naught is z bar, I naught is x plus a1 a1 कितना है भाई a1 कितना y bar a naught bar a naught is z I1 is also x. So you can take z bar common, y plus y bar chalega, so x z bar is the answer. So none of them satisfying. क्या हुआ? एक मिनट में चेक कर रहा हूँ. Because when none comes, we should cross check second time also. It is suggestible. 0, 0, 0, 1. 1, 0, na? 1, 0 means it is I2. Yeah, it is 1, 0. Na? It is I2. I2 is nothing but y. Y into y bar is 0. So your answer is f equal to x, y, z. Yes, option A. Because none आएंगे तो हमेशा एक बार गलती हो सकते है क्रॉस चेक करना चाहिए कंपलसरी. So x, y, z bar is the answer. Understand guys? Enable तो compulsory 1 होना चाहिए भाई. So enable तो 1 होना चाहिए तो compulsory A input में 0 होना. Z compulsory 0. That is A naught permanently fixed to 0. In the A1 A naught it can be either 0 0 or 1 0 only. So when it is 0 0, its expression is A1 bar A naught bar into x. And when it is 1 0, it is A1 A naught bar into the I2 value, that is y. So A1 is connected to y na, so y bar z bar x, y bar z bar y. Y into y bar तो 0 हो जाएगा. So y x y z bar is the answer. Okay. चलो नेक्स्ट क्वेश्चन. Read this question. Both the figures are same. There is no place I can keep this here. Okay. 4 by 1 multiplexer shown in the figure, same as per IEEE convention shown in the figure 2. Both are same, he is saying. Okay. So ABC are the shown. What is the output will be? Last 10 seconds. So you have a 4 by 1 mux shown in the figure, same as IEEE convention shown in the figure is fed with 3 logic inputs ABC as shown. The output of the mux will be. What is the output of the mux? Here, one way is to represent IEEE standard. This is how it will be represented. And again, it is same. This is your S1. S0. Whatever may be, the rule is same. S1, S0 are 1, 0. First position, next position, CD. So what is the output here? I told that logic na take a K map. Here, BC are the selection inputs. A is the input 0 1 0 0 0 1 1 1 1 0. So when BC 0 0, your input is 0, the next input is A, and the next input is 1. So here, listen carefully. So when BC 0 0, you should fill with 0, and here you should fill this column with A. A means this one. Fill this column with 1, fill this column with again A only. A means again 0. So it is sum of the midterms 3, 5, 6, 7. 3, 5, 6, 7. ठीक है चलो next sum of the midterms 3, 5, 6, 7. One more important, yeah. Abhi to almost all the questions are done except 3 questions. These 3 questions are little lengthy, maybe for electrical engineering exam point of view, little difficult also. But abhi tak jo questions kiya na, if you are able to solve at least this part, mostly 99% until unless the exceptional case where your exam is really very tough. अभी तो प्रीवियस ईयर का पेपर चेक किया तो इलेक्ट्रिकल का क्वेश्चन डिजिटल में इतना डिफिकल्ट तो नहीं आ रहा है बट आएंगे तो you will be able to solve if you are able to do the next 3 questions. I am not able to, you are not comfortable in the next 3 questions also, that is fine, no problem. The remaining part, if you are okay, so most of the cases you will be able to succeed in the exam. So let's go for the next important question. इसके लिए 1 मिनट में 2 मिनट ले लो. Read the question carefully and try to answer it. So you have a 1 by 8 dmux, the d input address s0 s1. So 10 seconds more, but meanwhile I'll try to convince you with the question and its meaning. You need to make a 1 by 8 dmux. You need to make a 1 by 8 dmux using 2 to 4 decoders. Decoder or demux internal structure more or less will remain same. So you have a 1 by 8 dmux. The data input d in address inputs are s0, s1, s2, s3. Okay. Uh, Fine. So what is firstly 1 by 8 dmux में क्या होता है sir? S2, S2, S1, S0 will be selected from all zeros to this way Y0 to Y3. Here Y4 to Y7 will get the D in. So S2 is the bit which will decide first part or second part to get the D in. Here they are active low, so when by default all of them are ones. When anything is selected, that particular bit will become DN. It may be 0 or 1, but when the remaining bits will be by default, it is 1. By default, it is active low. Okay, all are 1. Selected, that output bit will become. Okay, the remaining. चल, this is the concept you should keep it in your mind. ठीक है भाई. अभी तो so it should, this enable should be depending on one particular bit S2. When S2 is 0, first part S2 is 1, second part to be selected. That is done. That is done by the help of here the bit which is common for both of them is Q. You observe carefully. You observe carefully. Okay. If Q equal to 0, this line will be 0, this line will be 1. 1 plus anything is 1. When you give 1 here, this will be disabled. And this will be 0 plus P. P will come. It depends on the P. It may enable or disable. Okay. So RS are connected to A1, A0. So A1, A0 are the selection inputs of S1, S0. Understand what I am saying? So here the Q will be connected to S2 because that will decide if suppose S2 is equal to 1, 1 plus anything is 1 now. This will be disabled because it is active low. So that 1 will come here, 1 bar is a 0 and 0 plus what is your P will come and the P will decide the output to be given to the P bit will be transferred here. Suppose now you see here S1 is 1 0. Okay, then all other will be by default ones. Here the P will come here. How P will come here, sir? Because if P0, it will enable and make this value 0. Because active low na, when that is decoder mein that is selected, it will become 0. Suppose P is 1, it will be disabled all at once and this Y2 also getting 1. But Y2 is affected, Y2 is affecting based on the P. P equal to 0 mein it is getting 0 because it is getting enabled and active low mein 1 0 will give you 1. 1 0 will give you 0. But when P is 1, it is disabled and you get 1. But P is changing with respect to this, sorry, Y2 is changing with respect to P because of 1 0. I have taken as an example here. So that P will affect one particular bit at a time. Suppose if it is 1 1, this will be affected. Remaining bits are by default always they are at 1 only. Whatever you have given here, that will be selected. Remaining will be staying at 1. So my P will be acting like a DN. Okay, P which is common. Okay, here also. Actually, P, suppose when it is 1, then what happens? This will become 1 and this will become 1 bar 0 plus P, P will come here. Okay, so you can understand that part. So when Q bar is equal to 1. So you can understand here, the data part is D in must be P, You see, if you take PQRS, what are the inputs you should give? P is equivalent to DN, and Q is doing the job of S2, and RS are doing the job of S0 and S1. Yes, because A1 is connected to S and A0 is connected to A1, A0 are connected to S and R respectively. So PQRS must be DN, S2, S0, S1. Here understanding the question is more than enough to answer this kind of questions. It looks very complex, but it is not that much difficult. You can definitely answer it if you are able to understand the read the question properly. So now if you read 1 by 8 DMUX with D input, S0, S1 are the selection input, S0 is the LSB, S2 is the MSB. More information he is giving, that's all. Lengthy question is always easy. He is giving you more information for you. Why not bar 2, Y7 bar are the 8 demultiplexed outputs, okay, required for us. Using 2 by 4 decoders, I want to use it with enable input E bar and address inputs A0, A1 is shown in the figure. I need to connect a DIN of the DMUX S0, S2 such that to PQRS, but not in the same order. You are connecting the order which is required for the design. That is this particular order. What is that order is the question by the exam. Okay, right. Now let's do some adder का questions. एक दो questions में छोड़ दिया ना, so वो भी खत्म करता हूँ. पानी है क्या? हाँ. Thank you. Just a minute. Try this question. Time up. देखो, in the figure shown shows the ith full adder block of the binary adder circuit. CI is the carry input, CI plus is the carry output. Assume the logic gate is having a delay of 2 nanoseconds each. Okay. With no additional time delay due to the interconnecting wires, and if the input A, B are available and stable throughout the carry propagation, the maximum taken, so already A, B is available, okay, and stable before throughout the carry, the maximum taken for CI to produce the steady state CI1. So already this is available at time t equal to 0. It is already applied before, okay, and that AI and BI are already applied. Actually, you should be little clear before carry itself they are available or not. Okay, okay, fine. Assume maybe are already stable and this is available. Okay. Now after applying carry, how much time is required here is 2 nanoseconds. And after applying the carry here, how much time is required here? This will require 2 nanoseconds and 4 nanoseconds. Okay, so one answer is if AB are already existing before applying the carry itself, because this statement may little confusion or little clarity to missing hai. This case may after applying carry, how much more time you require is to generate the sum 2 nanoseconds, carry 4 nanoseconds. Because already this input is readily available. Okay. नहीं sir, अगर I mean in this case 4 nanosecond is the answer. If AB is not readily available, maybe you get this at 2 nanoseconds. Okay, this is available at 2 nanoseconds. So this is available at 0. Okay, and another 2, it will require 4 nanoseconds. This input comes at 4. In that case, it requires 6 nanoseconds. Okay, what I am saying is if AB is applied and readily available before applying the carry itself, in that case, what happens is this output is readily existing. Once you apply carry, 2 nanoseconds are sufficient to get the output. And once the carry is applied, already this input is available. This plus 2 plus 2, 4 is sufficient to get the output. That is generally asked question, no doubt in it. Nahi hai to, if AB is also applied parallelly, in the first stage it happens, then it requires 2 nanoseconds for this particular, and after applying carry another 2 means 4 nanoseconds to get this. 2 pay this is applied, 0 pay I mean a time equal to 2 nanoseconds you get this. Another 2 means 4 nanoseconds may you get this. Another 4 means 6 nanoseconds you get this. That is if both are not applied both are applied at the same time. But already existing AB is present according to the statement if I assume. So at time t equal to 0 you apply, you get this at 2 nanoseconds. Time before 0 these are available. Okay, understood. That is the assumption. In that case, 4 is the answer. Now the last question for today's class. Yes. Read the question. 2017 GATE में दिया for both, I think, ECE पे दिया, electrical also it is given or not, I'm not very sure, I don't remember. Take 2 minutes of time just to understand the question and try the answer. Here, that n minus 1 times carry plus maximum of sum and carry वाला formula तो काम नहीं करेगा. क्यों sir? Because इस case में inputs are specified, internal circuit is given. I already told in the last lectures, when input is specified, internal circuit is given. Don't apply the formula of n minus 1 times carry plus maximum of sum and carry वाला formula. So please try. Last question for today's class. That finishes your combinational circuits. Tomorrow we start happily with the sequential circuits. बस टाइम तो हो गया. So maybe you tried, you get it or not, leave it, I will explain. You have a 4-bit triple adder realized using the full adders, and the figure 2 shows the internal structure of each full adder. I'll draw it, don't worry. Mm, The propagation delay of XOR gate, AND gate, and OR gate are given as 20 nanoseconds, 15, and 10. Assume all bits inputs are 4-bit adder are initially reset to 0. At time t equal to 0, the 4-bit adder changed from 1100 to 0110. So combinational circuit notes, I want to remind you, I'll share in my Telegram channel here. You just join this Telegram channel. Tomorrow I will share this entire notes of combinational circuits. Okay. Inputs are 1100, 0100. The output of the ripple carry adder will be stable at a time t equal to how much time? Okay, sir. Here the input is 0100, and the z naught equal to 1. If you add them, first output is 1, 0, 0, 0, some 0 carry 1, some 0 carry 1. This is the output. अब ऑब्जर्व किया तो एक इंपॉर्टेंट बात तो ये है, this one neglected. Why neglect, sir? क्योंकि ये neglect क्यों करना, sir? Please understand, my dear friends. Here already all of them are stable at 0 initially. Initially, all of them are at 0 only. So already this is stable. Whether you are applying 0, in between also it is not changing its value. It is permanently constant at 0. So no need to worry about the time taken, because it is not giving any carry to this position. Here also it is 0, but it is giving carry. Okay. So this addition does not generate, it does not require any time. You can neglect this. So you calculate this part independently and these two parts independently. You will get the answer. So full adder 0 and full adder, this is 0, 1, 2, 3. 0 and 2, 3 you should consider. 0 you should consider independently, 2 and 3 you should consider. So firstly, let me draw the figure, or can I copy this? Let me check. I don't think that will work. Let's draw. What is the difficulty? Let's draw in the same way. Hmm. So for the full adder, just last question here. Full adder 0. This requires 20 nanoseconds. This is 15 nanoseconds, 15 nanoseconds, 20 nanoseconds, and 10 nanoseconds. So here you are giving X naught, Y naught, and Z naught. What are the inputs? Just tell me. 100. At time t equal to 0, I am applying this as 0, 0, and this as 1. But all the gate outputs are at 0. Already they are at 0 only, right? If you apply here 1 at time t equal to 0, 0 into 0 already 0, it will not change. So already it is available. 0 plus 1 XOR gate will be 1. At what time it will do it? Just I applied a time t equal to 0. Already it is 0 only. So another 20 nanoseconds. So what time it will change its value is 20 nanoseconds. Now it is also already 0. You have given. So 0 into 1 is 0. 0 plus 0, 0. This is a permanently 0. It doesn't require any time. So you need not consider the carry time, because in this case it is not generating the carry or not changing in between also, because when before applying or after applying the input, the output remains the same, because one input 0 hai to AND gate ka dusra input can be anything, it is 0. You applied this is also 0 na? So 0 into 0 will give you 0 plus 0, 0. So carry is not having any effect in the output carry. This is your CI plus 1 and sum. This is the first case, full adder 0. Now, full adder 1, you can neglect. FA1, neglect. Now, FA2 and FA3, let us analyze. क्या हो रहा है? FA2, FA3. So, X2, Y2, Z2, X3, Y3, Z3. That is S2, Z3, S3, and Z4. So, this is the final part. Now, you know what are the inputs? What is the input you have applied? So, this is 1, 1 and this is 0, 1. So, apply this. At time t equal to 0, you apply this 1, 1 and 0. At time t equal to 0. Okay. So, initially Z3 का value कितना 0 है. ठीक है. Initially it is at 0 only. Now ध्यान से सुनो भाई, थोड़ा सा कॉम्प्लेक्स दिखते हैं बट इट इज नॉट कॉम्प्लेक्स. सो दिस आर द इनिशियल कंडीशंस. एट टाइम t इक्वल टू 0 मैंने 1 1 अप्लाई किया. 1 1 XOR गेट को दिया तो ये 0 ही हो जाएगा. सो इसका डिले कितना 20 नैनो सेकेंड्स, 15 नैनो सेकेंड्स एंड 10 नैनो सेकेंड्स. ओके. नाउ 1 1 यहीं पे दिया तो इट विल गिव यू 1 इन द आउटपुट ऑफ द एंड गेट एट 15 नैनो सेकेंड्स. अब एक इनपुट 1 है तो और गेट का दूसरा इनपुट छोड़ दो. और गेट का एक इनपुट 1 है तो immediately after 10 nanoseconds what is the output you get is 1. 1 plus anything is 1. बट ध्यान से सुनो, 15 नैनोसेकंड्स में मैंने इनपुट अप्लाई किया, another 10 चाहिए, total 25 nanoseconds is the time to get the carry. I applied this input at 0, then I get this at 1 nanosecond, I mean 15 nanoseconds, then this will go at 15 plus 10, 25 I will change the output. And anyway, Z2 is permanently 0. Okay, initially 0, after 0 also, so no need to change its value. So sum will not change here. So carry comes at 25 nanoseconds for this particular. So this will come at 25 nanoseconds. So now listen carefully. Here 0 and 1 will give me 1. How much time is required for this? 20 nanoseconds. Now 1 and 0, 1 and 0 will give me XOR gate. Now 1 and 0 will give me 1. At how much time? Another 20 nanoseconds, 40 nanoseconds. Now this 0 will come here. Okay, now see here. Similarly, all are zeros, 0, 0 or 0 into 1, सभी zeros है, कोई change नहीं. अभी क्या होता है ना, carry is applied. At what time you are applying this carry? At time t equal to 25 nanoseconds. This 0 will change to 1. मेरा 1 0 तो change हो गया ना, 1 जैसा, ये 1 यहीं पे आया, ये 1 यहीं पे आया. So now what happens is this 0 is changed to 1, 0 is changed to 1. At what time, sir? 25 nanoseconds. अभी ध्यान से सुनो भाई, 1 and 1 will give you XOR gate का output में 0. At what time you apply the input? 25. So another 20 is required. Another 20 में 1 1 will give me 0. So another 20 का मतलब क्या sir? 45 nanoseconds. Sir, very careful, very careful. If you observe carefully, there is a chance of committing a mistake. It is initially 0, after also 0, sir. Initially 0, after also 0. But you cannot negate the time in this case because it is not stable. It is not stable. This is condition what we call hazard. Even it is initially 0, steady state में 0, बीच में it is giving you some 1 here. Na? This is called as hazard, static 1 hazard. That is, the output is in between changing to 1 and coming back, transient state आके 0 आ रहा है. Okay, because of the internal delays. Okay, छोड़ दो. Now come here. This is 1 and okay, this will is also 1. At what time I applied this one? 25 nanoseconds. So another एंड गेट का डिले कितना 15 है ना. सो 15, सो 25 में ये अप्लाई किया तो 1 into 1 will give me 1. At 25 plus 15, 40. 40 में अप्लाई किया तो 40 plus 10, 50 nanoseconds में 1 plus anything is what? 1 plus anything is 1. At what time you get this? 15 nanoseconds. Understand what I am saying? 25 nanoseconds में मैंने ये कैरी को अप्लाई किया. Another 15 nanoseconds के बाद 1 आएगा because already this is 1 waiting at 20. Okay, because if it is a AND gate, both are to be 1, then only you get 1. But if any one of them 0, output is 0. OR gate में एक input 1 है तो दूसरा input you need not read also, you can blindly change to 1. So 1 into 1 will give me 1 at 20, you applied at 25 plus 15, 40, 40 plus 10. At what time? 15 nanoseconds you are getting the home. So this is the how the output is changing steady state में 15. Actually you don't analyze the first full adder also, okay, because इसमें maximum delay कितना sum के लिए 40 nanoseconds. Here what is the maximum delay? 40 nanoseconds. What is the maximum delay for carry? It is 20 and 15, 35 plus 10, 45 nanoseconds is the max, provided all inputs are available. If you apply all the inputs, it requires 40 nanoseconds. This requires 20 plus 15, 35. Already by the time this input is available, plus 10, 45. So at any given cost, FA not answer will not be more than 45. But already if you get 50, you know it is 20. But without analyzing this also, what I am saying is, when the answer is already 50, okay, which is more than 45, which is the worst case possibility of this circuit, you need not analyze FA0 also, no problem. In exam, to save the time, you can skip FA0 also. Now in this case, this is the answer, 50 nanoseconds. Now last part in the question, find worst case delay for any input. कोई भी input apply किया तो worst case, can I use n minus 1 times carry plus maximum of sum and carry because input not specified, sir? No, no, no. Why, sir? Why, sir? Why, sir? क्योंकि here internal circuit is given, we should be careful. मैं तो already बताया ना, internal circuit दिया तो और inputs दिया तो any case में you should not apply this formula. So in this case, what is the worst case delay? You will be getting it is, don't use the formula. Okay, 4 minus 1 3 times, so 45 plus maximum of 40 comma 45 तो गलत है भाई. So इस केस में let's take this example. Okay. Suppose here worst case we don't know the input, na 20, 20. Sum will come at 40 nanoseconds. Okay. You applied x, y, z. Once you apply the z, na, okay. Here z is applied at time t equal to 0. Right. So this requires 15 and 10. Okay, this is very available at 20, na 20 plus this one 45 nanoseconds mein carry will come. First stage, this is the condition. Next stage pe what happens? XY are available at time t equal to 0. So 20 nanoseconds mein it is already available. So here also at t equal to 20 nanoseconds already it is available. This is applied at 45 nanoseconds. Now after applying this at 45 nanoseconds, this requires the time of 45 plus 20. And after applying this at 45 nanoseconds, this is 15 and this is 10 because you don't know the input. Worst case possibility is 45 plus 25. So this case may, because these are already calculated, it is not a simple directly 3 input exclusion OR gate. Until you get the third input, you don't need to wait for the total output. So here this is internal part is already calculating first half, so it is saving time. So extra how much time it is requiring from one stage to another? 45 plus 25. So next stage may this will come at 70. So 70 plus 25. Next stage it is 95 plus 25. 120 nanoseconds is the answer. After applying the carry, another 25 nanoseconds are required because sum comes at 20, na, which comes late you should consider because at the last stage you should consider which one comes in the late, because by the time you are getting the carry already sum is coming, so no need to worry about the sum in this particular question. So carry plus extra time of the next carry plus extra time of the next carry. Last stage में you should check for both sum and carry, but anyway here sum का time कम है ना, no need to worry. Okay. So that is the answer. In this case, 120 nanoseconds. You can generalize the formula also, but like this you can analyze and write it is perfect. So when internal circuit is given, don't use that formula of n minus 1 times Tc plus maximum of Ts comma Tc. Once apply the carry, extra 25 is required to next carry. Extra 25 for next carry. By the time sum is already generated, you need not worry about the sum. That finishes today's class. Okay. An internal circuit not given, you don't know it is a direct 3 input XOR gate or not, or not. In that case, maybe it is different. You can use that formula because here even inputs are not given. Worst case possibility we have calculated. Different inputs may require different time. That finishes the combinational circuit for you guys. With all good questions. So the new batch has started guys. मैं तो signals and system शुरू किया. आप लोग subscription लेना चाहिए तो आज ही ले लो because आज तो 36% off भी है. You can take this subscription. This is my Telegram channel and this is the code for getting maximum discount on Unacademy subscription. Right? So this is the test series. IMT is going to happen guys. Last 2 weeks, 2 exams are available. Don't miss this opportunity. Please write this exam and check your rank. Commit the mistakes. Recover it. Overcome by the next final examination. Thank you very much for your time. Tomorrow we start the very important chapter of sequential circuits. Thank you.